Alright guys, so here's our second video. We're going to go through test conditions and then working with our calculator how to find the data that we want. Okay, so landline surveys. According to the 2000 census of all U.S. residents aged 20 and older, 19.1% are in their 20s, 21.5% are in their 30s, 21.1% are in their 40s, 15.5% are in their 50s, and 22.8% are 60 or older, not percent, 60 or older. Okay, so that's what the survey says that the breakup for the U.S. residents are. Okay, the following table gives the age distribution from a sample of U.S. residents aged 20 and older. The members of the sample were chosen by randomly selecting or randomly dialing, landline telephone numbers. So basically just had a computer programming all these different numbers into it. Okay? All right. Do the data provide convincing evidence that the age distribution of people who answered their landline telephone survey is not the same as the age distribution? All right, so let's go with our hypothesis. Okay, now we're used to saying H naught and then the mean is equal to something else. Okay, but if you look here, we're not really looking for the mean, we're not looking for proportion, we're just comparing that, saying, hey, we think that this is different from this. Okay, so when we're doing a chi-square goodness of fit, we actually have to write out a sentence, my personal favorite, sarcasm, of our hypothesis. So what I do is I look at the question. So I'm looking here, and I think that is going to be a great hypothesis. Okay, so I'm going to come up to here, I'm going to say the age distribution of people who answer their landline telephone survey, landline telephone survey, is the same as the age distribution of all U.S. residents. Okay, so there's my null hypothesis. Okay, now my alternative hypothesis, I'd go the age distribution of people who answer their landline telephone survey is, ready for this, not the same as the age distribution of all U.S. residents. So that's the main difference right there. So our hypothesis, we have to come up to here and say that it's a verbal sentence. And I'm usually going to take it from what they're asking me to find. Okay? All right. So our conditions that have to be met, take a wild guess what the first one's going to be. Most of you are probably grumbling on your breath right now that independence is the first one. Okay? You're absolutely right. So this is met because all the, let's see here, all the residents are independent of each other. Okay, so once independence has been met, what's our next one? And you're all yelling random. And that was stated. Okay? Next, after random, you always get your 10% condition. Okay? So we got 1048. I should just be less than. I apologize. 10% of all U.S. residents. Okay? And then our next one is going to be large counts. Okay? Now, the large counts is just going to be a little bit different for us on this one. Okay? That doesn't even work. So the large counts is all of the expected values are bigger than 5. Okay? So, I'm going to pause it real quick, make my table. I'm just going to use this right here. I'm just going to put it on another sheet of paper so we can do that. Okay? Alright, so here is our categories, our observed value, and I'm going to show you how I'm going to get my expected. I'm going to take my observed value, and I'm going to use what we're expecting it to be. So this is going to be 1.91%, which gives me 26.931. And then this would be 186 times by 0.215, and that gives us 39.99. And then 224, 0.211, and that gives us 47.264. Then 221 times by 0.155, and we're expecting 32.705. And then we're going to take 286 and multiply that by 0.228, and that gives me 65.208. Alright, so what I want to do now is I want to use my calculator. Okay? So, I'm going to go to my list, make sure I have everything empty. I don't. Alright, so go back to my lists. I'm going to put in 141, 186, 224, 221, 286, and then 26.931, 39.99, 47.264, 32.705, and that's going to be my second list. Okay? Alright, so next I'm going to go to my test, and I'm going to move to D. Okay? So observed L1, expected L2. My degrees of freedom is going to be 4. And so then I get a chi-square value and then my p-value is that guy right there. Okay? So once I have all that, then I need to come in and find my... anyway, sorry, distracted. Ha! Oh, guys, what's my p-value? P-value 0. That's what I need you guys here for. Okay. So 0 is less than 0.05. So that means we failed to reject H naught. Okay. So then I need to come up to here and say, there is convincing evidence that the age distribution So there is our value. It's the same thing that we have. So we're able to have that great continuity that we've had before. You get to see it again through here. Okay? So some final thoughts. Some crazy information. Crazy info. Okay? The mean of our chi-square distribution is equal to the degrees of freedom. Crazy. So, if we get a, I don't know, what was our degrees of freedom here was 4. We got a chi-square value of 3508.81. So it's unusual. So that's why we can sit there and go say, yeah, this is pretty unusual. But if I had, say, a chi-square, let's just say that let's say that's 5.6, right? It's not unusual. Okay? So then we could, that's why we're basing this off. Okay? Your variance is going to be 2 times the degrees of freedom. And then the median is equal to, well, it's approximately the degrees of freedom minus 2/3, but your degrees of freedom have to be greater than 2. Not equal to 2, it's got to be greater than 2. So it's approximately your degrees of freedom minus 2/3 above 2. So if it's a 3, then you go 3 minus 2/3, and that would be 2 1/3. So, oh, almost forgot. So our homework, the first one's on page 693. We're going to do numbers 2, 4, and 6. Homework number 2 is going to be page 693, numbers 8, 10, 12, 16, 19 through 22. And then, as always, I appreciate the guys that have been emailing me. We'll just keep working on it that way. And if anything comes up, please get a hold of me quick. All right. We'll talk to you later.